All right, welcome to another session. Today we're going to be looking at Fusion and Fusion 360 to be able to create a parametric modeling. The parametrics of Fusion will allow us to create uh, any one product in with just a couple dimensional changes will allow us to change the entire model product. So what we're going to be kind of designing and working on over the next few weeks is making this craft table. Jeannie at ShopBot, I helped her with this table. This is her table that we cut. Everything that we see cut there was done in using VCarve Pro, which it works just fine for that, and it did what we wanted to do. Now she has a friend that would like to make the very similar craft table, but she doesn't want it to be the same size. Well, working with that in VCarve Pro, you kind of almost have to start completely over. And you got the basic sizes, but it's most likely all the parts you'll end up having to change every size part. So what we're going to be looking at and exploring with is how we could have all of the parts going into the model to make a craft table like we see it here, and with only a few dimension changes to have it automatically scale all the parts to then fit and also be able to lay them out on the material. Another reason that this is very useful is not only can we scale for the overall project, it might be that we have just some slot together type furniture that we've designed, and material thickness makes a difference when you're working with slotted material. And again, working in VCarve Pro and Aspire, when you have a slotted piece that you need to have together and you go a bigger, thicker material or thinner material, well, it's quite a bit of effort that goes into having to change the width of that slot. So that's where Fusion and the parametrics come into it. It is hopefully not difficult to use, but it is a little bit. It's not hard once we understand how it functions and it works, but it is a different way of creating and drawings and modeling. The first main difference that we have with Fusion is we don't have this sheet layout size that we have with VCarve Pro. So that's kind of the first understanding. And then the other thing to think about is just we're working with 3D models, not necessarily the drawing what we're going to cut yet. So what we want to do is model up the actual parts and kind of worry about how we're going to lay it out and cut it later. So what we see on the screen right now is Fusion 360. It is I believe it's still free for everybody to use that is non-commercial. As you see across the top header there, it says it is for personal use, non-commercial use. This version is. Then we have the main interface that is separated in different sections. So the left side that we have open right now is our file explorer. This is where everything is stored. Everything is stored kind of out in the cloud, which is great, especially if you use multiple computers, where if you open up Fusion on one computer and then design something, and then you go into the office using another computer, those files are still going to be listed here, and you're still able to use the same files. It is also useful, you're able to share files and share these folders to have kind of a collaborated design of items. So I got a question coming up. Is this the free version? Yes, this is a unsubscribed version. I mean, they know I exist, and they know who I am, and This would be the same version that you would if you did not pay for it. But again, that is for non-commercial use. So they expect you to pay if you're using it to make money. So we are making, like I said, this craft table. So the first thing I'm going to start off with is organizing the files themselves. So off on the right here, I am going to click a new folder and create a new folder and call it craft table. So starting off, there is nothing in the folder. It is an empty folder. And we have our design space that is an untitled design space on the left. We have different views that we're able to view from the top, front, and the home. There is the little, I don't know what he calls it here, the design cube or the orbit cube that you could click on and pivot the design around. Clicking on the top will view the top view, and clicking on any of the other views will show the different views. If you are first coming to Fusion and have not had everything set up completely yet, and you're like, well, it's kind of looking a little bit differently because when you click top, it may not be the Z up. So there's a couple things that I would recommend doing to start with, and that is clicking your username in the upper right and go to Preferences. And when the preferences open, we want the default model orientation to be Z up. Then there's a couple other functions that you might want to do if you're used to having the way you navigate through, pan, orbit, and zoom in, zoom out, different settings for that. I did check the reverse zoom direction and have that checked. So with that done, we're ready to start our design and create. We are going to be creating several parts, and we are able to create all of those parts under one file name. There is, as we go through the next couple weeks, we'll see the benefits of why you might want to do it as separate files or versus having all the models in one file. That may not make sense right now, but hopefully after next week, when we start looking at the assembly and how to put all of these parts together that we're creating today, you might see the benefits of making them separate and or the opposite. Even though today and for this training, I am going to have all of them together, I typically do not like to run it that way, other than it does making the whole overall project more parametric because we're able to share variables from one part to another. So that's the reason why I'm kind of making it the way I'm doing it today. And since you may have no clue what I'm talking about yet, so let's get into designing and drawing some items. The first thing I want to do is create a new component. A component is a part. So as we pointed out, we are making, let me open that back up again. I closed it. We are designing and going to make this here, which is made up of several parts or several components. So that's what we're going to create first. I'm going to come up here, right click, and select a new component. And we're going to give that component a name. I'm going to start off with the bottom. So I'm going to give it a name of bottom. And select OK. We have our browser tree that is listed here, and there is the new component that we just created, the bottom. Since I'm not worried about other files at this time, I'm going to hide our data pane here, and that is clicking these buttons right up there. That kind of shifts that to the side, gives us more real estate on the screen to be able to look around. The big difference that we have with Aspire or CAD, regular CAD versus parametric CAD like we have here, is we are drawing and designing a model. To create a model, we need a sketch to build the model from. So we have sketches and then kind of extrusions off of that. If you're familiar with, SketchUp, kind of works very similar. So the first thing we're going to start off with is creating a sketch that is up here in the top left. Going to click Sketch, and now it wants to know what plane, X, Y, or Z, are we going to create this sketch on. So I'm going to click on the top view here, and then click this top surface there. This opens up our sketch tools, and I'm going to come in and out of it a couple of times. So hopefully you're bearing with me and hopefully it'll all come together when we get something drawn here. So we have our tools across the top here for our drawing functions. If I want to just draw out a simple rectangle, clicking the rectangle tool, coming down to our drawing space, clicking once and moving over and clicking again. I'm going to finish the sketch by coming down here to the bottom right and click Finish Sketch. We now have in our design tree, we see a bottom, and then we have a sketch. Right now it is a single sketch, and that is what we have on the screen here. This is like a little eye that we could click off that turns that sketch off, and it turns it back on. If we want to model or change any dimensions on that sketch or change the size, right click on the sketch and select Edit. Brings us back into the Edit tools for the sketch. And again, we could click Finish Sketch. To give this some thickness, rotate this around just so we can see that it is just, made up of lines, has no thickness yet. I'm going to use the Extrude function. And you just click and extrude. So I'm really not paying attention to exact sizes on anything yet. And this is just the very basics on being able to model and create an object, which is just a basic block at this point. Now, we are going to create and draw out the bottom, and I believe I have a picture of this here is what we are going to start creating. So we've started out with that main sketch, and the size of that sketch, I want to be the overall size of that bottom. So again, to come back in and change parameters about that sketch, I'm going to right click on the sketch and edit. I want to add dimensions to this and be able to set the size. So this is where we start seeing some of the parametrics of Fusion. So dimensioning is more than just dimensioning for a drawing or for a presentation. Dimensioning is constraining an object to a set size. So if I click the dimension tool and then come down and notice when you click over top of a line or an object, it highlights in a thicker colored blue. I'm going to click and just drag that up. And we have a dimension there that I am now able to enter in a size. So let's make this 80 inches. And that just grew out there to 80 inches. And I want to do the same thing for the other dimension, and let's make that 40 inches. So we now have a rectangle that is 80 inches wide by 40 inches tall. We could modify the size of these dimensions anytime we want by double clicking on that dimension, and we could make that 48. And we could see that all of that automatically changes. That is, if you're not familiar with it, that is kind of exciting. But it gets much better than that. So we're going to finish this sketch, and we're going to adjust the thickness of this. The thickness is what we have extruded that to. Across the bottom of Fusion, we have our what's called the timeline. This is done in the order of creation. So we've created a sketch, then we have our extrude, and nothing else done. We're going to end up building out more on this. We'll have more sketches, more extrudes, and more data here as we continue on. I want to edit this extrude by selecting it. I'm going to right click and select edit feature. And I'm going to enter in a dimension of 0.75. That's the material that we have for today. So that is the basic rectangle that we would use or have for the bottom section here. Now I did mention, early on that, material thickness, we may want like a global variable that we could modify in one place and have multiple items change. We could do that. I'll show that in just a little bit, but before we do that, let's put in some other dados. Maybe I have a dado running right down through the center of this board to create and hold and locate a center partition. So let's learn how to add that to our model here. I want to edit and create a new sketch. Going to create a new sketch, and this time, as the first time I selected the plane, the XZ or XY plane. This time I'm going to select the face of our 3D model. So that means all new sketches that we're drawing are going to be applied to the surface of this face. And to make that fairly simple, again, I'm going to bounce in and out of this a couple of times to show so we could see how the relationship goes. And I apologize for those that may already know all this. This, I think, is kind of the more challenging parts of Fusion to understand. And once we understand all the relationships, it makes everything so much easier to learn and use. So I'm just going to draw out a rectangle. Didn't worry about size or any of that. I just put that in here. And I'm going to finish the sketch. And just as I extruded the main sketch, I'm going to extrude this here, and we could come down with it. And I'm going to enter in a dimension of minus 0.375, which is half the thickness of the material. And we could see that that is what we have there. But that material or that dado is way too thick. We want to shrink that down and start constraining this to always be in the center of the width. And we also need to constrain the end. So if I ended up making the first sketch, let's just see what happens here. I'm going to edit this sketch. And instead of 60 inches, let's go ahead and just to make it very long, let's go ahead and make it 120 inches. We'll then finish this sketch, and we can see that that dado no longer goes all the way across. So that's what we're going to focus on now and figure out how to always have this dado stay within the center of this object and also within the length. So coming back into the first sketch, I'm going to bring that back down to a manageable size of 72 inches this time. So we have, again, our main sketch, and then the sketch that is applied to the face of that. So that is what I want to edit, coming into Edit Sketch. And now we're going to start looking at how to constrain our drawing objects from one object or to the other object. Constraints are just like the dimension that we put in, and that will be and could be the first constraint that I give it. So I'll give it a dimension constraint, and I'm going to enter in 0.75 for that dimension. And I always want to have the width or the length of this dado to be the same length from the outside to the outside. So you might think, well, the best way to do that is dimension this line here to be 72 inches. Well, yes, that would work, but we want to make sure that that rectangle, that dado, is going to increase in size when we change the size of our main sketch. So the first thing I'm going to do is click the coincident constraint. This is now able to say, I always want to have this point be the same as that line here, is on that edge. So you see how that just kind of moved over? And I am going to come over to the right side and do the exact same thing, use a coincidence constraint from that corner to that point right there. And that now means no matter what size we change the main sketch to from 72 to 120 to 48, this dado width is always going to be the width of that main sketch. What we have drawn so far are drawing objects that we're able to extrude and move from. I always want to have this to be in the center of our sketch here. Now I did say that was 40 inches. So again, we could dimension this and say that I want to have this edge to this edge be 20 inches minus half of the width. Or we could allow it to automatically create and constrain this to the center. And the way I do that is I like to use construction lines. Some software would call those reference lines. So with that selected, when I draw in a drawing object, it is not blue, it is kind of this gold color. And that is just like a guideline or a reference line. And I'm going to use the same constraint that I used for this rectangle to say that I want to have this point to always be there, and the same for this point to always be on this edge. Going to look at another constraint here, which is a midpoint constraint. Not that we really need to have it, but just to help keep construction lines in a logical position. So I'm going to say I always want to have the endpoint of that construction line to be at the midpoint of that line right there, and the same thing for this bottom one. Now that in itself has not done anything to constrain the position of the rectangle. We could still kind of drag and move this around. The way I'm going to constrain to have this in the center now is use what is called the equal constraint, to where we are able to say, I always want to have this construction line. Let me undo that. To where we could say that I always want to have this construction line be equal to the width of this construction line. Now notice when I did that, my main rectangle there is no longer blue. It has become a solid black. That means that that part or that drawing object now is fully constrained and we cannot move that around with a mouse anymore. It is kind of locked in place and is always constrained to be really in the center of our main part. So we could finish this sketch and we could see that that will now always remain in the center regardless of what we set the dimensions to on our main sketch. So if I bring this down to 20 inches, we see that that dado automatically recenters itself in the center of our main sketch. I'm going to open up that main sketch again and increase back to 40 inches. And if I haven't said already, which I think I did, please feel free to interrupt or use the chat window. I try to keep the chat window open and visible. And I see there's already been some help there. Thank you for helping out there. But yeah, use the chat window. It is we're here to help and learn. So it's asking about why not use, yeah, I mean, there's several ways of constraining a part to be equal. So what I could have done and what's being pointed out is instead of me using the construction line here and setting it equal to equal, I could have set this line to be constrained to the midpoint of this one. That can be done, absolutely. There is no right or wrong to the way you constrain it. The one thing that I would do, or I like to do, especially if you're collaborating with a lot of people, trying to be consistent on the way you constrain parts in models. So when you're working on a model that somebody else created, it is somewhat obvious on how it is. One reason that I did this, not to say, like I said, you could use those midpoint. I put the construction lines in there that way, and you see the equals constraint right here. It becomes obvious to me when I open this same model up a month from now, and I want to like move something or readjust and wonder why that is not moving. It's sometimes hard for me to see constraints that are kind of hidden off to the side. But if I come in, open up this model, and I see a construction line top and bottom, that kind of tells me that I was constraining it in such a way. We will see more constraints on how to connect short lines because we're going to have several dados, just like what we created here in the center for the other one. Now, we're seeing constraints. Hopefully you guys are getting excited about this because it's exciting just being able to change one dimension and have the whole thing like automatically change. We're going to take it one step farther now, and because we have this dimension here of 0.75, which is the same dimension as the material thickness. Here. So if we cut this project today and we have 3/4 inch material, but tomorrow we want to cut the project again, but we ran out of 3/4 inch material, we only have 5/8. Well, that means we're going to have to go into each one of these sketches and modify that dimension 0.75. Yeah, it's not hard to do. You just open that up. But there's some magic here that we're able to make that much, much, much easier for us. And we use that and that's our variables. Let's see what they call them. I can't remember. Parameters is what they're calling them. So coming up into modify and coming down to change parameters. Now I'm going to give a warning about variables, and I'll say it again after I show what they are. Be careful on how you use them. New users to parametrics in here tend to get overuse variables and make a lot of variables that aren't necessarily needed. So really put in thought to what variable names you use and how you use them. So let's see what a variable is. So coming up here to modify and change parameters, and we are going to add in a user parameter. We'll end up coming back in here again and adding another one, but I'm going to first add, click the plus sign, and I am going to say, and the expression, meaning the dimension of 0.75, and we'll say OK, and then OK here. So we do have a name of material thickness, so I'm going to say OK. Coming back into our main sketch, or I'm sorry, our dadoed sketch. And we have this dimension here. Remember I said we could double click on that and change the dimension. If I want to make that 3 inches, we could do that. Automatically goes to 3 inches. And because we have our construction lines that are equal to one another, that stayed in the center. But now here's the magic of that variable that we just created. I'm going to double click here. Rather than putting in 3 inches or 0.75, I am going to put in, start typing material. And we see that it automatically pops up our variable here. So I'm going to click on that and say OK. Now it gives us a little prefix there that's indicating that that is a user variable. And it is at 0.75. So now what that means is when we come up into our change parameters, let's scoot this off to the side, I could enter in a new value here of 3 and enter. And we see that that automatically grew by 3 inches. This is like an infomercial, but wait, there's more. So one thing that you were looking at, and we have to do quite a bit, is, a 3/4 inch thick material, putting into a 3/4 inch wide dado is probably not going to fit. You're going to need a good sized mallet to smack that into that dado, into a perfect fitting dado. We want to make that dado just a little bit bigger, maybe 10 thousandths, 0.1 thicker. And we always want it to be that thickness. So I'm going to right click and edit that sketch once more and double click on that dimension. And now we have our material variable listed there. I am going to say it's material thickness plus 0.01, then enter. So now that is always going to be 10 thousandths bigger than whatever value we entered in there for that variable. Variables could be used wherever a dimension or a size is used. So if you remember, we specified the thickness or the main extrude, which is this extrusion right here. So I'm going to select edit. And remember, we set that to be 0.75. Instead of being a hard-coded 0.75, I'm going to enter in to use the material thickness there as well. Since this is the actual thickness of the material, I'm not going to do any math for that. We'll just leave that to be that thickness there, and we'll say OK. So let's go ahead and create two more variables. We have on our main sketch the length and width. Today we're doing a 72 by 40, but tomorrow we might want to do 80 by 48. So let's go back in and create two more variables. And the width will go 72. Let's go 40. You got to think about how you're going to use these variables as well. And then we'll do a length. And we'll go 72 there, and we'll say OK. So with those two new variables in place, let's modify our original sketch and change our hard-coded dimensions here to our newly created variable dimensions. And dimension or variables are made up names. They could be whatever you want them to be named. Something somewhat logical that is representing what that variable is actually doing is best practice, but it could be named whatever you would like it to be named. So we now have somewhat of a parametric part that is easy to change and always keep a dado in the center. And again, to change any one of those sizes, it's coming back into modify, change parameters. And now if we change this from 72 to 84, we now have a piece that is 84 by the 40, and that dado is still remaining in the center. Yeah, getting ahead of me. Yeah, that's a good one. That is where we're headed now. So what about the dado thickness, this material? So right now, we hard-coded this distance dado right here to be a depth of, I think it was 3/8 of an inch. So say if we were going to cut this out of 5/8 material, that dado could be a little bit weak at that point. So we really want to have some sort of relationship to the thickness of this dado, to the material thickness. Now, pay attention to that negative sign in front of that value right there. That negative is saying that we are going down into the material. So if I just put the material size in here, it is not going to go down into the material by that setting. It's going to be projecting up. That's not what we want. So if remember, two negatives make a positive, a negative times a positive makes the negative. Well, you know what I'm talking about. So we're going to go -1 times material thickness divided by 2. So that is going to allow us to control the depth of that dado based on the material thickness. So hopefully everybody is starting to see the benefits of this. Now, some of you might be, head spinning a little bit, trying to understand what's going on. Another bunch of you is probably saying, well, just move on with it already. I understand it. Well, we're taking it slow, and hopefully by next week, all of you will be able to do and create a parametric model like this. Then so that we could continue on with assembling this and kind of checking the fit to make sure everything fits together. So Paul is asking if there is some sort of data table kind of behind the scenes somewhere. There could be. I am not familiar with it, so I will try to answer that question next week and get that answered for you. So let's just move on and create one more dado or a couple more dados, and then we'll look at how to add another part or create another component. Yeah, well, one question that is brought in, you could. The question is adding the tolerance. Could we add a variable to add in that tolerance? I added that 0.01. So yeah, you could add and have a variable that's called tolerance. And that is where I would caution you a little bit on that might be getting a little bit into the realm of, overthinking variable names or over variabilizing, if that's a word at all, the parametric model. But yeah, so I kind of want to think of when you're creating a variable, will we ever need to change this in the future? If it is yes, we are going to need to change the size of this width or this tolerance a lot, based on material thickness and all of that, then yes, you might want to add in some sort of tolerance variable. But if regardless of material thickness or anything else or material type, your tolerance is always going to be that 0.01, I would not go in and make a new variable for that. But let's go in and focus a little bit on creating another dado, or actually a couple more. So I want to create a couple dados on the face here. So I'm going to select that, where before I was selecting the sketch or create sketch, then the face that I wanted to create the sketch on. This time I'm clicking the face, then on the create sketch. Either way works. As you see, this time it just automatically brought us into this. So to quickly or more quickly go through this, I'm just going to draw out a couple rectangles, and I am not worried about sizes yet. Just put 3 of them in there. And now I'm going to start constraining these. Again, we have our coincidence constraint that I want to make those always the same size. There. Now, my next step that I'm showing, there are several ways about going about it. This is my method. I'm just making them different lengths to show one more constraint here. And what I'm going to do is create a construction line. From the endpoint out from each one. Now notice that really did not go to a construction line, but another line did. So this line right there is a construction line. Well, it was selected when I clicked that button. So if any lines are set as not a reference line, but an object line, you could select it and come over here to the line type and select it and tell it that it is a construction line. So the reason why I moved these to different lengths is to show the 2 variables or constraints that we have here. They're a horizontal and vertical constraint. For those that are coming from SolidWorks or Inventor or other programs like that, you usually have a horizontal constraint and a vertical constraint. Well, Fusion has linked those together, and it is pretty smart about which one it wants to do. And it's going to pick, in this case, it's going to go horizontal because these lines are more horizontal than being vertical. So now when we move 1, all 3 of those dados, rectangles, shift and change size. The other thing that I like to do is make them all equal to one another because I always want to have those the same size. I could come in and set a dimension to each one. That would work just the same way, but I like to minimize the amount of dimensions and use the constraints. And that is so that when you come back into it later, you change one variable and they all will change the same. So my next step is creating all of these rectangles to be equal to one another. So now when we change and drag the width out, you can see all three are going to the same size. I also want to point out that, see, we have this light blue line that is making up that rectangle, and then the back section of this line is black. So the black line is saying that's constrained to this line. You're fully constrained there, but the blue, we are not constrained. So what happens and can happen at times where if we have, say, a dimension on a line, or if we want to, if I said, let's have this always be to the same size as here. Let's go ahead and do it this way. I apologize. Skipping around. So let's give this a dimension from here to here and say that I want that to be inset maybe 1 inch. So we have the back side is constrained, the front side is constrained. Well, what about the depth here? Can I set that to be a number? No. So I'm getting a message that says that I'm over constrained, that I can't do that. And the reason that I'm getting a message like this, you could get it frequently until you start kind of understanding where and how the constraints work. So what has happened here is I am locked in and constrained to the backside to this dado. I also have the front side constrained, which means that the width of this line here cannot be changed other than by changing the width of our main sketch. Hopefully that kind of explains what that is, but it's just over constrained that we can't have more than one variable that controls the width. So we have a constraint to the front. We don't have one on the width. So this is where I am going to use the dimension again for this one and setting it to be the material thickness plus 0.01. Now we still are not yet fully constrained. I know that because we have these blue lines there. We could still move them right to left. It might be now that I'm going to set some fixed dimensions here because I'm always going to want a shelf off to the right. I always want that space to be 14 inches, and the space between these two here, I always want those to be 18 inches. And then the space in between these two, let's set that one to be 24 inches. So now you see that they are all black, meaning that if I add a constraint to any one of any more here, I'm going to get the message saying that I'm over constrained and I can't change anything. So we're good there. That's what you want to see. You want a fully constrained part. So I'm going to select Finish Sketch. And we will extrude. These parts the same as I did the center dado by -1 times material. -1 is converting the positive to a negative. And then I'm going to divide that by 2. And now we have our dados to put a center partition in. Now, with that created, there's still more work to do in here, but we're kind of running out a little bit on time here. But we've got this component. We've been working on the bottom. We need more parts to completely finish out our design. So to add another part, we don't want to create another sketch within the bottom section. We want to create a new component entirely. So I'm going to right click and create a new component, and we'll call that just say par for partition. And we see that now in our tree, we have the bottom and a partition here. If I don't want to see the bottom part, just hide it. But I'll leave that open and draw out on the top view a new sketch in just the same way we created this sketch here. Going to use the rectangle tool, draw out the size. Dimensioning is going to be based on how high do we want this. So let's say we want it to be 26 in this direction. But now we have this dimension locked in here. I'm not going to get the math right the first time, so I'm going to try and attempt to do it, but we'll see. So what we want to do is set this dimension to be equal to the width. I'm going to go divide by 2. And we want to subtract out the width of the dado. So let's see if that is right by material thickness. And we were 1 inch in from the front, so I'm going to go a -1 and see if we get lucky. I might have gotten lucky. I don't know. We could use a measuring tool to do that, to check that. So that says that is 18¼ inches. I'm going to finish the sketch, select that object there, and I'm going to extrude it to a thickness of the material and say OK. Now let's see if that 18¼ is, or 8, is that what it was? Now we'll learn how to use our measuring device right here. So click the measuring tool to click on that line, and that is 18¼ inches. So that's good. And let's see if it matches up to. It did not. So there's something in my math that is not quite right, but I hope you guys got the understanding of the dimension or that use of variables and the use of being able to do math with inside of that variable. I could always come in and modify and edit this sketch and modify my variables and the dimensions by coming in here and making the modifications. So I think it is, I did not divide. Maybe the material thickness probably also needs to be divided by 2. And there it is. So we could see now that by changing the main variable under parameters, changing the width, I'm going to shrink this down a little bit just so we could see the magic happen. We have 40 inches wide right here. So coming in here, say if we don't want it to be 40 inches, we want it to be 35 inches. We see how this got smaller, and so did our partition that we have here. So that is what parametric modeling is all about and how it works. And what you want to be able to really do is think about how all the parts are going to be constrained by one another, how you're going to use variables. Sometimes you may want to pre-map out what variables you're going to use, because it is very easy to get over, it's very, you could very quickly get too many variables in there because you think you need them at the time. So you create a variable, and before you know it, you have 110 variables in there that you can't make any sense of. So keeping variables to the minimum and only what you would really need to use. So this kind of concludes today's session on creating parametric parts. I will be here for just a little bit longer, hang out to answer some questions. But next week, what we're going to do is I am going to finish out some more of these parts between now and next week. And we will then look at how we constrain those parts to fit here. So when we are all done, we'll know that all our parts work, they fit together, and we could share the actual final design and actually be able to create a rendering that is almost photorealistic of what the finished part in project looks like. So by the time we're done, hopefully by end of our session next week, we will have something that kind of resembles what we have in this screen. And with a quick adjustment of a couple variables, we will completely be able to rechange the size of every part that goes into it. So hopefully this wasn't too advanced or too simple. Hopefully it got the message across, and I hope that you all are going to be able to use Fusion.
Hey, Ryan, it's Donald. Thanks for today's lesson. So will you, or the process be after all these parts design, or putting them in VCarve Pro for tool pass, or making the tool pass in Fusion, a couple weeks out at the end of this?
Yes, we're going to do both. We are going to look at how we would lay these out in Fusion to be able to do all the tool pathing directly in Fusion, which is, again, adds to the power of parametrics, because all of those tool paths would automatically change based on the overall size. Now, the challenge that we have within doing this within Fusion is there is no nesting abilities and really no sheet size layout that makes it easy to get laid out. Then we'll also look at how to create drawings that we could import into VCarve Pro or Aspire and use the nesting functions there. So we're going to show both.
Okay, great. And I take it there's post processors for ShopBot and Fusion 360?
There is.
Great. Yeah, look forward to it. Well, thanks again.
So I have some questions that have come in through the chat. Somebody asking about what setting did I use to make it come into the flat plane automatically. So, well, moving these around, there is the orbit button here. So if I want to view it from the top, I'll just click the top view. And then we have the zoom to fit buttons down below. Hopefully that is answering the question. Another question that has come in through chat is just wanted to see, take a look at my preferences. Once more, upper right, you have your username. Selecting preferences opens up the preference screen. So the dimensions for the the cubby area here. This is, I'm thinking kind of out loud again now. So these, you might want to, I'm hearing cubbies. It might be that you have a set storage area that you're wanting to see or set to. I'm going to point out one more thing here. Sorry. So you see this little option here that says that I'm editing this part right here. If I want to edit the bottom, I'm going to set that option there so we could view what our this sketch is to see those cubbies. We may want to set up a variable that specifies the width of a basket or a bin or some sort of device that we had there. So there are the variable dimensions for like the cubbies. So yeah, fillets, definitely. That's a design possibility, especially what I might want to do is even though our model here shows this being square, that is not square. That is going to cut to the radius of whatever our bit is. So I would use a 3/8 diameter cutter for this. And so what you might want to do to avoid having to put, dog bones or, T-bones or anything in there, what we might want to do and what we can is add a radius to the outer sections here, and that is could be done right here under the tools. I'm going to select this line here and say that I want that to be 0.187 and do the same thing on the other side. Should have clicked on both at the same time. So now we've created a radius on the edge of our parts that we could use a router table or a hand router to do later, or the machine if we wanted to do as a flip operation. With the fillets, I'm one that would rather put the fillet on there rather than a dog bone or a T-bone. Especially, a fillet kind of makes that a little smoother, eases the edge a little bit, and just makes a nicer fit. That is my opinion, if it matters at all. Wow. Yeah. So the challenge differences, someone's asking about Fusion versus cabinet making software. The biggest thing between using, even though we're able to design and lay out and parametric cabinets within Fusion, as we are doing, using a dedicated cabinet making program will allow you to much more easily get all of the parts nested out and laid out on a sheet of material. It'll be a little bit more straightforward of a process and just much faster overall. Even though we are, parametric here in Fusion, we still have the tool pathing that is kind of parametric, but not really. It is a little bit of a challenge getting them laid out, where dedicated cabinet making software is much easier and quicker. All right, that is going to end it for today. Thank you all for joining us, and look forward to seeing you next week, and really look forward to hearing what kind of challenges you may have run into, see if we can't get those corrected and use those as learning experiences. Everybody have a good week, and we'll see you next week.